All right, hey, how's it going, everyone? Hey, just wanted to record this week's Zoom review session for you guys for the PM class, juniors and seniors. I know we last week reviewed batteries and things like that, and we didn't get a chance to get to that Zoom meeting to do some review on that. So hopefully this session will help out with some of that. Obviously, we can't get into a lot of the testing and diagnostics of that part of it, not being in the shop right now. But hopefully once we get back to the shop eventually, juniors next year, we can jump on knocking these tasks out. And seniors, I hope some of this helps you guys a little bit along with the task and procedural videos and skill drills posted in the CDX for reference. So let me share my screen here with you guys. All right, so I want to go over a little bit about automotive batteries. So obviously the most common type of automotive battery you guys are going to see and deal with is a lead acid type. There are going to be some other ones we're going to talk about here in a little bit, but the most common you're going to see is a lead acid type, usually located under the hood of a vehicle. And it is considered a starting battery as opposed to a deep cycle battery. And we'll get into deep cycle batteries in a little bit. The standard 12-volt car battery has 6 individual cells. So if I can turn my little pointer on here, you will see 1, 2, 3, 4, 5, and 6. 6 individual cells with each cell having the capabilities of producing 2.1 volts. So if you add all that up and do the math, a fully charged battery should equal 12.6 volts. Most people have the common mistake or misconception that 12 volts, when they see 12 volts on an open circuit test on a battery, that it is fully charged. It's not. It's actually a discharged battery. 12.6 volts is a fully charged battery. 12.4 is about 75%, and so on down the list. All right. So, like I said, each cell contains 2 sets of electrodes or plates immersed in an electrolyte fluid. And here's a nice little breakaway of a battery you guys can see. So remember that 12.6 volts is a fully charged battery because each cell produces 2.1 volts or has the capability of producing 2.1 volts times 6 cells. I mentioned deep cycle a little bit ago. So here's an example of a deep cycle battery as opposed to a traditional starting battery. Deep cycle batteries may look a little different. A lot of times some deep cycle batteries look like a starting battery other than a few minor details. All right, but the one thing about them is they definitely have heavier lead plates in them. They tolerate deep discharging way better than a starting battery. And they are heavier and bulkier than a starting battery. So they definitely weigh more. They usually take up a lot more room in most cases. So an example would be if you lifted up the seat of an electric golf cart, you'll see a bunch of deep cycle batteries wired together under there, and they are a lot bigger. So that is not starting batteries in a golf cart. Those are deep cycle batteries used because they tolerate the constant charging and then complete discharging and then charging and discharging a lot better. All right. A low maintenance battery, you probably hear that term of a low maintenance. They require little topping off, if any, of water, but they do still have removable caps. So you can see right here, these have cap covers you can pull off for each cell. Let's go back to the last one. Or they have these style caps on older batteries. But they still have the caps you can take off. You can add water or check the specific gravity using a hydrometer. So there is still the capabilities of doing that, but they need very minimal attention. That's why they call them a low maintenance. A battery you guys are going to see a lot more coming in the future is an AGM battery or an absorbed glass mat. They're not new. A lot of people think this is a new thing. They've been around for a long time, but you haven't seen them very often in your traditional everyday passenger cars. You usually come across these in, for example, European cars have used them on some higher-end European cars for a while now. You've seen them in off-road vehicles, specifically built, for off-road or race cars, because they do have the electrolyte in a gel format instead of a liquid. So that is absorbed into the mat of fine glass fibers with inside the cells. So these have the capabilities of being bounced around a lot more and being laid in different positions on their side. They don't have to necessarily be upright like a lead acid battery does. If you turned a lead acid battery on its side, it would leak. And then we have sealed or maintenance-free batteries. As you can see here, they have no caps that you can remove. That means they are maintenance-free. You cannot maintain the level of the electrolyte. You cannot check the specific gravity electrolyte, anything. I can't adjust it, fix it, nothing. So it's a maintenance-free or a sealed battery. A lot of these, you'll see this visual indicator here, and they usually have a little chart here on the top of the battery like this one does from BMW. They have a green, a black, or a yellow. So the green usually means it's good, black usually means it's bad, and a yellow means it's on its way out, so you better replace it. The problem with these is this is just one cell. This is basically a hydrometer reading for one cell. So this cell could be reading okay, and the other one's maybe getting weak and you wouldn't know. Gives you the information on the status of the charge and the condition of the battery cells. But like I said, this is just on one cell, so don't always rely on these. Some of the common locations, everybody knows that you see batteries under the hood of cars, right? But on a lot of late model vehicles, they are not under the hood anymore. How many times have you guys opened the hood of a car and you're like, well, where the heck's the battery at? And you may see jump starting posts or battery cables running to somewhere, but they're not under the hood right in the core support or in the fender well like they used to be in the old days. Sometimes they're down inside the fenders. Sometimes they are under the the cowl panels. A lot of times now you're going to see them under the back seats. Cadillac, looks like an example of a Cadillac. Cadillacs have had them under the back seats of some of their bigger cars for years, since the early 2000s and maybe even into the late 90s on some cases. But I know for sure in the early mid 2000s, Cadillac DeVilles and DTSs, they had them under the back seat. You may see them under the floorboard. Some Mercedes vehicles I've seen under the passenger side seat. You have to take the seat out and remove a trap door to get to the battery. So you can see them under the hood, obviously, and you may see them under the seat, in the trunk, under the floor pan. So you're always going to have to refer to the service manual if you can't find where the battery is. Some of you guys may have heard of battery group, that term. This is especially useful if you're working in a parts department or dealing with a parts department or a parts store. They may ask you the group number, or you'll hear them talk about a group number. And you'll see on here all these different group numbers. That stands for the size of the battery case, the location of the battery terminals, and the size or type of the battery terminal. So if they look up, it's a group 75 battery, it gives you a general size of what that battery is going to be, which side the positive and negative posts are going to be on, and what size or type. Is it a top post, side post, things like that. So the group number specifies not only the size of it, but the location and type of terminals. It's very important to know. Speaking of terminals, here are your common battery terminals that you will see. The two over here that I'm circling with my highlighter right now, these are the most common, or the two type of vehicle batteries that you're going to see. Top post battery terminal, everybody's seen these. An eyelet or a ring type terminal slides down over this, you clamp it down, and that's it. A lot of vehicles, a lot of vehicles still use these, but General Motors really went to the side post cable back in the day. I would say probably back in the early 90s, they've been using those. It's a love-hate relationship with these. A lot of people hate these because they're very easily to cross-thread and strip out. They're hard to get battery, charger, or testing equipment leads connected to, because the clamping point is so small as opposed to this. But some of the advantages to the side post cable is this is all sealed, so there's way less chance of corrosion and oxidation in this area than as opposed to this that's open to the environment and exposed to the elements. A downside to this is if this does get corroded in here, you can't always see it unless you take it off and peel this covering back. And you can't usually clean them out good enough to put them back into service. So if they get corroded bad enough, you'll have to replace the whole battery cable. And then over here is a lug terminal and cable example. It's basically an eyelet to a lug terminal with a nut and bolt. A lot of times you see these on like lawn tractors, lawn mowers, things like that. Let's talk about some of the ratings of batteries. First I have listed here is the cranking amps, the cold cranking amps, and the reserve capacity. We're going to start with the cold cranking amps down here because this is what I like to use as a lot of the ratings for testing equipment, things like that. Most of the time the parts stores will ask you what the cold cranking amps are in the battery that you have, different things like that. A lot of testing equipment likes to use this too. So cold cranking amps, or CCAs, measure the load in amps that the battery can deliver for 30 seconds while maintaining a voltage of 1.2 volts per cell or higher at 0 degrees Fahrenheit. So you're cranking that battery when they test this at 0 degrees Fahrenheit, and you crank this battery for 30 seconds. That is telling you that this can hold or measure load of the amps. The battery can deliver 720 cranking amps for 30 seconds at 0 degrees and keep each cell with 1.2 volts or higher. All right. Now, people get this confused with cranking amps. Cranking amps is the same thing, just at a higher temperature, at 32 degrees instead of 0 degrees. So cranking amps measure the load in amps, but at a higher temperature. All right. Let's talk about reserve capacity, because this is one that's overlooked a lot. Most people don't talk about reserve capacity, but it's good to know because you can use this to figure out some testing and charging rates, things like that, along with the cold cranking amps is nice for charging rates. You can figure out, do the math and figure out what a charging rate would be. When you load test a battery, you usually load test it to half the cold cranking amps. And there are ways to figure out charging rates and testers that use reserve capacity as well. So the reserve capacity is a time in minutes that a new fully charged 12-volt battery at 80 degrees Fahrenheit, is how it's tested, will supply a constant load of 25 amps without its voltage dropping below 10.5 volts. This is approximately the amount of time that a vehicle could be driven before the battery completely dies if the charging system fails. So if you're driving down the road, your charging system quits working, it's not charging the battery anymore, it's 80 degrees outside, and you're supplying 25 amps of load to it. Maybe you have the headlamps on, radio on, a bunch of accessories on, whatever. It can keep this battery right here, could go approximately 90 minutes and keep it above 10.5 volts. All right. What's bad for the battery? Well, other than temperature, because temperature is really bad for batteries one way or the other. Fully discharging the batteries is tough on them. Having deep discharge cycles. So on a starting battery that's not designed for as a deep cycle battery, a starting battery does not like to be discharged and then charged and discharged and then charged. That's hard on them. Remaining at overcharge or undercharge. So if you have a charging system fault where it's not charging the battery enough, it's going to weaken the battery. Or on the opposite of that, if it's overcharging the battery constantly, it can damage it. Experiencing high discharge rates for extended periods of time. So if you have a parasitic draw and the car sits for weeks at a time, that's not good for them. Experiencing excessive vibration. So that's why a lot of times you'll see a gel cell type battery in an off-road vehicle. A lot of vibrations in race cars or off-road or things like that. Maybe working on a job site will shorten the life of the battery for sure. Being exposed to extreme temperatures, whether that be extremely cold or extremely hot, dirt or moisture on the case, that creates a case drain, as we call it. It'll actually create a draw across that battery case, and of course corrosion. So remember, regular maintenance is a good thing in the vehicle overall, but especially with the battery, because the purpose of regular maintenance of the battery includes leaving you stranded somewhere. That's what you're trying to avoid, is leaving you stranded somewhere or the customer stranded somewhere. Nobody likes to come out from dinner and turn the car on and it doesn't crank over. Also avoiding damage to the starter and electronics, because a weak battery can cause damage to that stuff, and just overall extend the life of the battery. Regular maintenance of the batteries includes, but not limited to, periodic inspection, cleaning, testing, and keeping it charged when it's discharged. And here's some examples of checking electrolyte level on batteries that you can do that on. This is kind of a transparent looking battery. Sometimes they may have lines where the fluid should be between. Most batteries, you can't see that. They're a black case or a case that you can't see through, and they have the removable caps. So on that style battery, the electrolyte should be near or touching the bottom of the fill hole. Some other maintenance checks we're talking about here. You can use a digital multimeter to measure voltage across the top of the battery. So we're taking the one lead here, the red lead, and putting it on a battery post, like the positive post. And we're taking the negative lead or the black lead and just running it across the plastic case. If we pick up any voltage, like this is a very dirty battery, I bet you would see a ton of case draw or a case leak through here. You would see any kind of voltage going across there. So any voltage greater than 0.2 volts or 200 millivolts means the battery should be cleaned, because just sitting there while the car's off, that dirt and corrosion will cause a drain of the battery, a little bit of a draw. All right. Here's an example of a heavily oxidized battery post. You can see it's not very shiny. That creates resistance in the circuit. That's a problem. You want to get it cleaned up so it's looking nice and shiny and making contact like this. Along with the battery post, you want to clean the terminal ends too, because this needs to be making good contact along with the cable ends. So make sure you're shining up and cleaning the cable ends too. There are special sprays that you spray on the corrosion to neutralize it. It foams up, you let it sit for a couple minutes and it will neutralize it. Baking soda and water solution mixed up together and brushed on to that stuff will neutralize the acid too. You always want to neutralize this stuff with some sort of a spray or baking soda and water mixture before you start handling it, because it is nasty stuff. And notice this guy's wearing gloves. I tend to always recommend to wear gloves when messing with the battery. Even if it doesn't look dirty, there still could be some leaks or corrosion on there. So use the sprays, clean the stuff up, use the tools to clean it, and then also when you're done, they make a spray too that's a sealer. I like to spray a sealer over top of the terminal and cable. Once I have it all cleaned and connected back up, it kind of just acts as kind of like a clear coat or a sealer to keep from corroding again quickly. How often are we doing this stuff? Maintenance tasks should be performed, periodically. So for top post batteries, a good rule of thumb is inspect, clean, and fill the batteries every 6 months to 1 year if they have removable caps. Same with side post batteries, inspect, clean, and fill the batteries if they have removable caps. But on a side post, a good rule of thumb they recommend is every 1 year to 2 years. Because on the side post, they have those, the better seal, a little more of an airtight seal between the cable and the terminal. So there's a little bit less chance of corrosion and oxidation building up on there. So that's why they extend that a little bit. You're charging a battery. Remember, slow charging is way less stressful than fast charging. Everybody's impatient, myself included. Battery's low, car's in the shop, you're flat rate, you're trying to make money. You want to get it charged up and get back on the road or get it out of your bay. But avoid fast charging if at all possible, because fast charging creates a lot of heat inside the battery. If you're not paying attention to it and you charge it too quickly with too high of a charging rate, it can actually start to boil the electrolyte and create excessive hydrogen gas. So that becomes a dangerous situation. And it's also damaging the battery. The plates inside the battery do not like that. So slow charging is ideal. All right. So here's some ideal charging rates right here. And I like to go by CCAs. So an ideal charging rate is whatever the CCAs are divided by 70. So get your phone out, get your calculator out, get a piece of paper out and a pen, and write the CCAs down and divide that by 70, and you will find your ideal charging rate. All right. A max charging rate, if you have to do a fast charge, is the CCAs divided by 40. All right. So things to remember though, never exceed 15.5 volts when charging a 12-volt flooded cell battery. That is overcharging. It will damage the battery, overheat things, not good. All right. 14.8 volts when charging a 12-volt AGM battery, and 14.3 volts when charging a 12-volt gel cell battery. These are things to never exceed. So realistically, you shouldn't just throw a battery charger on a car and walk away from it for 2 days. You should check it periodically by doing an open circuit voltage test, at least with a multimeter, to make sure you're not exceeding these for these types of batteries. Now remember, these are just a good rule of thumb, so it's always a good idea to check the manufacturer specific or OEM specific requirements for charging batteries and things like that. So doing a state of charge test, there's two tests for determining this. The most common and probably easiest test is using a hydrometer. So right here is an example of a hydrometer. It looks like, for those of you that have used a coolant hydrometer, it's a very similar concept. You're using a specific gravity test to measure the electrolyte specific gravity, and that indicates the acid content, and then you can figure out the state of charge. So you're taking a small sample of the electrolyte from each cell and checking the specific gravity on the scale, and that will tell you which each cell, if it's good or bad, or low or weak, okay? You can also use a refractometer for this, and same with the coolant. You put a drop of the electrolyte from each cell on here, close the lid, hold it up to the light, and you look at the battery fluid scale, and it will give you a specific gravity. The other state of charge test that you can do is the open circuit voltage test by using a digital multimeter. That gives you a good voltage measurement of the battery, and it can act as an accurate indicator of the state of charge. That's a quick, easy test that you can do. So here's some tables for reference for you guys down here. So specific gravity and corresponding state of charge. If you looked on this scale and you had a 1.265 or higher, you know it's 100% charged. 75%, it's at 1.225. So an easy way that I've always figured this out is just move the decimal point over. So if I got a 1.25, I move that decimal point over, it's 12.65. So I know 12.6 is a fully charged battery. I move the decimal point over, it's 12.25. I know it is about 75% change. You know, 12.2 is about 12.2, 12.4 is about 75%, and so on and so on. Now you have to take into account the temperature, and some of these hydrometers have a temperature correction scale on it. Some of them don't, okay? So on this chart, it's the state of charge indicated by a voltage reading. So doing an open circuit test, if you're reading 12.6 or greater, it's 100%. 12.4 to 12.6, 75 to 100. Oops, sorry about that, guys. 12.2 to 12.4, 50 to 75, and so on. All right? So those are two easy tests that you can do to check the state of charge of a battery. Here's an example of doing an open circuit voltage test. We have it on volts DC. We have our meter lead set up right, black to common, red to the voltage port, positive to positive, negative to negative, and we take a reading. And this is 12.4. All right. So it's a little bit discharged. It's not quite a full battery. We can also use a conductance tester to test a battery. This is a common tool that you'll see Advanced Auto Parts or AutoZone, any of the parts stores, and they come out and test. A lot of times they use a conductance tester. A lot of manufacturers are recommending conductance testers now. They're quick, easy to use, and they give you a pretty accurate overall determination of the battery's condition. So it determines a battery's cold cranking amps capacity by measuring the conductance of the battery. All right, it sends low frequency signals into the battery, which allows it to determine the battery's ability to conduct current. So it's basically sending a little bit of some small signals through the battery and seeing what comes back out, and it's seeing if it's conductive enough. Then the heavy load test. This gives you more of an accurate reading of what the battery's capacity and internal condition is. It's subjecting the battery to a high rate of discharge. So you're putting an extreme load on the battery, and then you're determining how quickly that battery, or if that battery can resist that load and how quickly it can recover from that load. So voltage is then measured at the end of a set time to see how well the battery creates that current flow. The disadvantage to a heavy load test is you're actually stressing the battery while you're testing it. So this is a carbon pile style tester. We have a Sun VAT45, a Sun VAT40 at the school. That was the pretty much industry standard load tester for many years. Then we moved to a digital Sun VAT45, which is the same type of a load tester, except you don't have to turn the dial. You input some information into it, basically push a couple buttons, and it does the load testing for you. Now we've moved on to things like the Midtronics GR8 and some other type of handheld testers where they still do a load, but it's all automatically controlled and fairly automated for you guys. All right. Maintaining presets and computer memory. That's called the CAM, or the Keep Alive memory. here's an example of what we use for years. A memory saver, you can put in the cigarette lighter, a 12-volt power adapter with a 9-volt battery. I know you're thinking, well, it's a 12-volt car, what's a 9-volt battery? All it was meant to do was to keep just enough energy or enough power where it would maintain the radio presets and things like that. So you don't have to reset all the radios for the customer when you're done. If you don't have access to this and a customer's car needs a battery disconnected for any reason, at that point, you really should get a pen and paper and write down all their presets. And then when you're done, install those presets back in for them. That's usually what's expected as a service. So I started using these a long time ago, so I didn't have to do that. Now, as vehicles progress, there's more and more accessories. There's seat presets. There is steering wheel tilt presets. There are radio presets. There are XM radio presets. There are all kinds of other computer memories that need to have some sort of a constant access to power so they do not lose their memory. So today it's a lot better. Now we recommend using a jump pack with a memory saver cable. It goes into the DLC or the data link connector. It just kind of keeps the computers awake while the battery's disconnected and keeps them just enough power to save all their presets in memory. Factory resets after battery replacement. This is something that on every vehicle you need to look up. Here's an example out of the service manual. Checking the OEM recommended procedures is key. Some systems or computers may need a special relearn procedure after battery replacement. Some cars you may have to go in and not just reset the radio, you might have to reset throttle position, you might have to reset or relearn auto stop window positions. There may be little things you have to do, and it might be just something as simple as rolling the window all the way down, rolling the window all the way up, and then testing the operation of it. But you don't know until you go look in the service manual for every vehicle. So here's an example of work steps required after reconnecting a battery. You always want to make sure that you do this because you don't want to send a car down the road and then a customer come back with something not working correctly when you could have just taken care of it in 5 minutes with a quick, simple procedure, or sometimes just a scan tool reset. Parasitic draw. What a drag, what a drain. It's a common problem that you guys are going to have to deal with more and more. As more and more electronic systems and computers and accessories you're putting on cars, more and more chance that you're going to have something malfunction and cause a draw. A draw is when the ignition is off and there's still power going to something. Too much can drain the battery, causing customer complaints. So nowadays, a lot of times, I mean, even under normal circumstances, if you leave a car sit for a few weeks, it may have enough of a drain that's acceptable that may create a slow start or a slow crank condition. We had customers in the past when I was in industry that they came in and said, well, my batteries was slow crank, or it had to be jump started. And I said, well, how long did you drive? Well, it hasn't been sitting that long. I said, well, where was it? Well, we were in Florida for a month and it sat at the airport for a month. And I said, well, and I'd show them where GM had in their technical bulletins and information, things like that, that after 2 to 3 weeks of sitting like that, it may drain the battery, especially depending on the temperature. If it's really, if it's in the middle of winter time, it might amplify that as opposed to the spring. So draws are always there. It's just a matter of nowadays making sure the parasitic draw is within an acceptable limit, okay? So you measure it with an amp meter, measuring milliamps. Old-fashioned way was disconnect the battery, hook up the amp meter in series with the battery cable, let the car power down and see what your reading is. It's preferred nowadays to use more of an amp clamp because now you don't have to open up the circuit. Because every time you disconnect or reconnect that battery, you're spiking computers and waking them up, and you're not getting an accurate reading. So if all possible, an inductive amp clamp is the way to go. But you can still do it the old-fashioned way with putting the amp meter in series with the battery cable. All right, so that's all I have for you guys on that right there. So let me get off my screen here. I hope this helped a little bit. I hope this kind of explained terms like specific gravity, state of charge, hydrometer, refractometer, parasitic drain and draw, stuff like that. So I know it'll be a lot easier to understand once we can actually get our hands on the stuff in the shop and check some draw on our cars and actually clean and inspect batteries and test batteries on our cars. But I hope this helped explain at least some of the vocabulary a little bit more in technical terms. So hope you guys are having a good week. I'm going to go ahead and get this done recording here, get it edited, and try and get it up on the YouTube channel and get it out to you guys. All right. Hope you have a good one. Thanks again. Wortman out.